Yes. And Wisconsin. With my knees in the final game with Auburn.
Bruce Pearl.
But I picked some upsets. It is, yeah. So we tried to get one bottle to go up. And it didn't really happen the way I thought. I didn't, creepy, that big 7.
Set up in case I have to go for people coming into their.
Okay.
Didn't want to disturb.
No, that's fine.
Yeah, I'd be in the middle of the video stream.
I thought we would have a few more, like, public folks tonight.
Yeah, we don't get many public.
Yeah.
Put it on Facebook and stuff, people ask us.
Yeah,
Yeah, but if we're not setting up telescopes, there's not gonna be much time.
yeah.
You know, we may be pitchless though, because EP Sawyer asked us if we would do something, they have like a monthly presentation, it's big type of presentations.
Mm-hmm.
And I told them we would, and then the person who's in charge of it left. They had a new person, and they haven't told me if they're gonna renew that, but I thought, telescope, something to have telescopes, so we can set up telescopes, and they'll advertise it to the public.
Yeah.
It's getting to the time of year where you can actually use a telescope.
Yeah, get out when it's a little warmer. Yeah.
You get one at Christmas and you don't get to use it until March.
Yeah.
I hope next weekend the weather's good.
Yeah, 'cause Aaron was talking about wanting to do the Messier Marathon, so.
Yeah.
Oh, then we got a 22.
There you go. Keep going at it, Tom.
Does that like blow out the screen or whatever when that comes on with this camera?
It's gonna wash out. It can look great.
Okay,
It's gonna wash out some more and see that.
okay, excellent.
So y'all gonna be out there Friday and Saturday?
I have to talk to him to see. I don't know if I could do 2 nights in a row.
I'm gonna go Saturday, because I'm doing a scout thing on Friday. Training scout masters.
Okay.
Things that they can do with their troops.
Okay.
New scout masters, people involved in scouting. So Eric Berenson and I are doing something out in Camp Crooked Creek.
Okay.
I'm trying to drag another person. There's about 70 people there. I'm gonna set up 2 telescopes, a Dodd and German equatorial. Show them different types of telescopes.
Yeah.
Try to get some out to Kirby, make us some money.
Yeah.
I'm hoping to recruit a digital telescope. I keep thinking about buying one.
That's why I usually just check.
I don't want to pay an $800 camera I've never used.
Oh, wow. You still have your Mac Newt, right?
Oh, yeah.
That one.
I restored it back to original. I got rid of the original finder scope I found in Spain.
Okay.
And then I'd taken and put a new focuser on it. I took the focuser back off. Took the original, which was a helical.
Yeah.
Took it apart and cleaned it real good.
You're waiting a lot.
I used real oil. Fishing oil.
Yeah.
Never,
Okay.
doesn't come up if it gets wet.
Yeah, nice.
I got a new boss menu down at G&P 11G.
Okay.
And fully all the bells and whistles. Before I quit work.
Yeah. So hopefully when we do, that's
All right.
It's hiding the
I
sun.
guess it's time for us to start from here. So what's the process here?
Just stand sort of where he is so the camera can see and let me know when you're gonna do it.
Okay, well,
Just the way you see
let me get to my need to my phone here. And we will, Steve's not gonna be here.
Right.
And
You'll think you're duplicating the same shape.
where do I look?
That's you good.
Yeah, kind of like where the,
Okay, well, I just need to know where,
or you can stand here
where
just like,
things are, you know, I'm not, I just walked in.
You could make cue cards.
I don't need a cue card. I need to find this. You folks.
No problem, just put my.
Perseverance, what's up?
what's up
I'm sorry, I thought I was done. Send it out as it's a lot.
But I had to roll
kind of
into
a-
it.
Light pollution
Okay. It's cloudy.
Almost didn't make it.
and, y'all ready? All right, welcome everyone to the March Louisville Astronomical Society meeting. I'm Pat Peak, I'm the vice president. Steve's not here tonight, so he wanted me to be the master of ceremonies. He didn't give me a report. Vice President's report is, you know, just our meeting. Next month, we have a really interesting meeting coming up. We have a special guest, and you have all that information be sent out to everyone. It's on the 11th next month, because on the 18th, we have Earth Day at the Parklands. So we'll be asking people to volunteer for that as well. We normally start off with officer reports, and any of the officers having anything to go over, anything new going on?
We're working on scopes out of Kirby, and, that's, at Peak and
Ed Heine?
Ed Heine and sometime next month, I'm gonna need some hefty volunteers to help, break down the railings, for the roof railings for the observatory, so that we can paint it, because it's in dire need of painting. And we've got some other painting that needs to be done, so if anybody wants to volunteer to help with that, that'd be great.
And we'll get up a list of everything that we need to do out at Kirby and put us together an action register and get volunteers. One thing going on next weekend is a good weekend if you want to try Messier Marathon. You'll be able to see all 110 Messier objects in one evening from our location. I think 2 or 3 of us may be going out to Kirby to try and see how many we can see. And so that
Next Friday or Saturday?
we're not sure yet. We're still working on it, but we'll let you know and who all's going to be out there. I don't think we'll need the observatory opened up for that, just to have the building open.
I do have, and this is not related to Kirby, but I have a request after this meeting. If you could go with me over to the UAC, I need to get that AVX mount that got repaired. I need to get it so I can take it up to Kirby. That's for the 90mm solar scope.
Yeah, we have a new door sort of put in.
Yeah, I don't have
At-
a key, so.
Neither does the new door.
Yeah, the new door doesn't either. It's kind of warped, so we're trying to get that door put in over there.
Well, I mean, you can get into
Yeah,
it, though.
we have to go
Yeah.
in from the back door, from the next area there.
And we have 2 doors.
Right.
So, and we have the keys for them. Finances, we're in a really good financial position. I see our treasurer's not here. But, you know, we have, I believe it's around $14,000 in the bank right now.
16.
Okay,
Yesterday.
around 16,000. So we're in very good financial shape. And we don't have any major expenses that we foresee coming up. So. Other officers, our lunar and planetary person is not here, but they sent me a what's up in March. We're going to send this out to all the members because it's really long. He's a little bit more long-winded than I am. Mine would be 1 page, and his is like 6 pages. So the primary things that this month is, of course, the Messier objects. We can see all of them. You can start it when it gets dark. Even if you can't see all 110 from your specific location, you can easily bag 100 of them. And if anybody wants to come out next week and see how good you are and spend the night out there, feel free. Planets, you have Jupiter and Mars are high up in the sky, and also Uranus is high up. Those are easy ones, easy targets to see. Constellations, there are a variety of constellations. Every constellation will be visible in March. If all the Messier objects are, then all the constellations will be. Deep sky objects, some interesting ones that are not Messier objects would be, you have the galaxies NGC 2303 and 2903. And we also, the good Messier ones are M81, M82. Planetary nebulas, we have the Clown Face Nebula. It's an interesting one, NGC 2392. And then we have the M42, of course, Mission Nebula in Orion, which has something, a really interesting little thing in there, a little cluster called the trapezium. And that's a good way to test your equipment, is to check out the trapezium, because you normally see 4 stars. As you push the power more and more, you can see up to 6 stars. So if you have good quality optics, you can usually pick up the 5th and 6th star as you push the power on it. It's a really interesting area to look at, and that's a place where you're having stars born. It's a star nursery. So, you know, I could go through, there's a whole list of this. We'll send this out to all the members. It's on Facebook. It's already been posted on our Facebook page. So all this information is available to everybody. Well, I think that's all for meeting things. Anybody have any questions about anything? No? Well, I'm going to turn it over now to Karl Schmidt here. Karl is going to talk about choosing and using your first telescope. And Karl's been around for quite a while. He's been into astronomy for about 40 years. He's been a member of this group a long time. And he's been a member of other groups here locally in the astronomy community. So, Karl, it's all yours.
All right, thank you. Okay, so tonight's program is going to be a conversation, and it's a conversation that continue after the program. It's based on beginners for visual astronomy. When it comes to choosing a scope, as you can see up here, there's a lot of varieties of telescopes and a lot to choose from. But my goal tonight is to kind of take these distant photons of light that travel and come to Earth and in through the telescopes, to kind of break it down in kind of like little bits to kind of understand what's going on. So the goal is here to bring the beginner to make an informed decision on what type of telescope they want to choose. Again, I'm going to explain about the optics, the mount, the eyepiece, and so forth. again, the price, I won't be posting any prices in the presentation, but again, we're looking for a beginner somewhere in the range of $300 to $800. And throughout the presentation, I'll show you what you can get. And then later in the presentation, if we have time, we'll go over some samples of that. So before you begin choosing your first telescope, what you want to do is actually know the night sky. You want to be able to go to several star parties, look through telescopes to get an idea of what you want to look at, whether that be distant galaxies, planets, the moon, and so forth. And how do you choose that will depend on your interest. We will, in my opinion, there is one scope that kind of gives you the best of both worlds. But again, there's no one telescope that gives you everything as far as planetary or deep sky viewing. So learning the night sky, normally you start out with a star map. Gives you kind of information about the stars and the constellations. Some of them give you locations of the planet and the moon. But starting out, it can be a challenging task, but hopefully here we can make it just a little bit easier. So since it's cloudy outside, I figure I'd bring clear skies into the room. This is the all-sky camera up at Kirby. The long pole that you see in there is actually the weather instrument, so we'll just kind of ignore that. But as you're looking up in the night sky, there's quite a bit you can see. You can see some bright stars, some bright objects. You kind of faintly see the Milky Way. So you want to, using your star map to kind of start, connecting these dots to figure out what you're seeing.
It's an eclipsing binary.
Yeah. We just had a nova just happened, so. So we take this, and I used the paint program to kind of connect the dots to give us an idea of the constellation. So looking back at the star map, now you can see, okay, we have the constellation Orion, we had the bright planet Jupiter, there's Mars over here.
Just had a nova.
Here's the North Star Polaris. So now, as you're learning the night sky, you're getting familiar with what's up in the night as far as planets and stars. So let's take this a little bit further. When we find the Big Dipper and the Little Dipper, that kind of gives us some information on what we can do to using star maps. So what is that? Well, the Little Dipper, we can use it to determine the magnitude of the stars. As you can see here, Polaris is a real, when I say bright star, not a real bright star, but it's at a magnitude 2. You can see it easily with your naked eye. As these numbers increase, they get much fainter. So over here, the 6.39 magnitude star, you can see it's very dim compared to Polaris, which is a little bit brighter. So you can use the stars of the Little Dipper to kind of gauge the brightness of the night sky. Now the Big Dipper actually gives us a measure of the night sky. The bowl stars here, for example, you have 7 degrees, 10 degrees. The whole dipper itself is roughly 25 degrees. So it can be your measuring tool. So how do we get these degrees on our star map? Well, we're going to learn a little bit of sign language tonight. So if you hold your arm at a distance, this here will give you an idea. So as we look at the Big Dipper, between your thumb and your little finger is about 25 degrees. So you can use that as kind of a reference to measuring the constellations. Another way is looking at a star chart. There's a lot of information on here. We'll begin here on the side. We have the declination on the map. We're looking at the celestial meridian, but if you notice here, from 0 degrees up is 10 degrees, and 0 degrees down is another 10 degrees. Now below it, it's a negative number, but it's still a distance of 10. But overall, we have a distance of 20 degrees here. As we can see, the constellation Orion is a distance of 20 degrees. Now in the right ascension, 1 hour of right ascension is basically 15 degrees. So this is another way that you can kind of have a unit of measure when you're looking at the night sky as kind of a reference. So let's see how we put that together here. So over here is Orion. So now we know that it's roughly, 20 degrees. So now we can start looking, say, at Gemini here. And we can see Orion and Gemini are close to the same size. So that's 25 degrees. We come over here to Pegasus, the square. If you kind of imagine taking Orion and putting it inside here, you'll roughly have 20 degrees. Or I'm sorry, 25 degrees. So now we start with our star map, and looking at the night sky, we can kind of get perspective of the size of the night sky. So how does this, help us with choosing a telescope? Well, it gives us an idea if you want to look at a binocular to get a rough idea of, say, the Milky Way here. Here's the double cluster, and we're going to look at Andromeda here. So we get a more detailed map, and again, having that 25 degrees here with the square of Pegasus, our target is here, Andromeda. So now we use our hand tool, and holding our hand at a distance, we can see that between the thumb and the finger is 25 degrees. The knuckles here are about 7 degrees, and then our target is Andromeda. So again, this allows you to navigate the night sky and help find your object. One of the things I didn't mention at the beginning, but I'd like to mention here now, when we're talking about the beginning of purchasing a scope, we're not going to look at scopes that automatically track or go to. Again, my emphasis is on learning the night sky. As you learn the night sky, learn the stars, the go-to telescope is a nice feature. But again, with a go-to telescope, the price really increases. So speaking about binoculars, we're going to look at our friend George here from Britain. He basically, over his lifetime, memorized the night sky, the constellation of stars. He just used binoculars for viewing, and he made a lot of discoveries of nova and comets. So binoculars is a good choice when you're beginning looking at the night sky. You have several types to choose from. You want to go with the Poro prism. Let me back up there. You want to purchase this from a reputable astronomy company. I mean, you can go to your Academy Sports and buy binoculars, but those are usually for a daytime. We're going to talk a little bit about the optics and the coatings that come here, but for starting out, if you're not really for sure what type of telescope, binoculars is a good choice. So what I recommend for a good beginner binocular is a 7x50 binoculars. You have a 50 millimeter objective. It's about a 7 power. It gives you a field of view of 7.8 degrees. So again, as we use that reference that I talk about with the 25 degrees with the Big Dipper, you can see that 7.8 degrees is about the size of the bowl of the Dipper. So looking at a little bit of the specs here, again, you want to look for a poro prism. The roof prism, they'll work, but this here will give you more clarity. What we really want to concentrate on is this here, fully multi-coated optics. We'll talk a little bit later about exit pupil and eye relief, but this is the key here, fully multi-coated optics. So what are we meaning by coated optics? Well, as light goes through a substrate, which could be a lens or reflection off a mirror, you do lose a little bit loss of light. It's about 5% for each pass of ocular that it goes through. So as you can see up here, that no coating, you have a lot of light that will scatter, that won't go through. And as you increase the coating on there, it actually helps with the transmission of light. So it's, when you're selecting your scope, you want to be looking for fully multi-coated. If it doesn't say fully multi-coated, we'll see that that can present some issues with your image. This ED glass here, extra low dispersion glass, it kind of helps with eliminating the color. If we think of a prism that Sir Isaac Newton had showed us, as light passes through a prism, you know, you get the rainbow effect of colors. The extra low dispersion actually helps minimize that. So therefore you get a cleaner image and not an image that has a lot of color to it. So let's look a little bit of example here with a lens without a coating. You'll notice here the moon looks blurry. Not all the light rays will come to a focus. You'll kind of see a red. And we got that nova again. We kind of see the red and the bluish color here where the light is passing through the lens and it's not coming to, all the light is not coming to a focus. So the different types of glass, and here we're looking at crown and flint, it actually minimizes the chromatic aberration. So what's this look like through some telescopes for comparison? Well, here we see on the left, there's an absence of that chromatic aberration. You can see the image is real clear. The lunar surface in detail is in focus. Everything looks crisp. As you go across, you can kind of see the color here, you know, from optics that are not coated and not using multiple lenses to help correct the aberration. Also, when you're looking, there's another term here, the apochromatic. And apo is usually is what you'll see in the listings of scope. And again, this is another lens element here that actually takes that light and does a better job at getting it all to a focus. And how you remember this, think of the P in apo means everything comes to a point. And also think of the P as pricey, because they're going to be very pricey, as we'll see here later. The achrochromatic, just think of the C here. You'll have a little bit of color, but using different types of glass, especially the extra low dispersion, kind of minimizes that, and the optical coatings help minimize the chromatic aberration. So we talked about binoculars. We're getting into talking about the different types of telescopes. The refracting telescope has a lens, the objective lens here, and it bends light to a focus point. Now, when I talk about a focus point, I want to think not just like a point, but think of an image plane, because what the optics is doing is taking something from very far and creating a small image that the eyepiece is going to inspect. So again, focal point, think of it as an image formed by the objective, or in a case of a reflecting telescope, a mirror. So again, the refracting has a lens. Other types of telescopes will have a mirror, and then some have a mirror here and a correcting plate here. So the reflecting telescope, again, you can see the light path come here, bounce off the mirror, a secondary mirror that brings the focus right up to the side of the tube to where your eyepiece goes to inspect that image. In the catadioptic, you can see the light path does bounce quite a bit till it ends up through a circular opening in the back of the telescope and brings a focus here. So again, in a refracting, we're going to see in a minute, we're going to learn about the focal length of the telescope. So a refractor, the focal length, the longer it is, the longer the scope. It gets into the reflecting and the catadioptic, where the focal length will kind of vary, and we're going to use the focal ratio to kind of let us know what is a long and what is a short focal length. Now again, there's many other different types of telescopes. I just want to show here. Back here is your normal Dobsonian. We do have some large truss tubes. There's also one of our club members has a telescope. It's called a YOLO. So I just kind of wanted to mention that there's more than just the three types of telescopes that we're going to talk about. So again, I talked about telescopes. It's going to range to $300 to $800 price range, and that's for a beginner. And you're looking at as far as a budget that's reasonable to get into astronomy. Over here we have our refractor. Again, it's on we'll learn an alt-azimuth mount. It has an arm here that holds the telescope. It's good for just pointing and moving left to right, up and down. Actually, with all these telescopes, they don't have no device to actually track or move. And what I often tell beginners is, when you're choosing your scope, you want to drive the scope, not have the telescope drive you. So all these here are just what I would say a push-pull. Now this one's kind of unique here. This is an equatorial mount. Polaris, the North Star, it points to Polaris, so these knobs here will kind of mimic the rotation of the night sky. We got that bright nova again. On this mount here, when we start talking about mounts, look at the size here. You want a mount that's made out of aluminum or something heavy instead of plastic. So you want something that's massive, that's not going to cause vibration. Of course, over here the Dobsonian mount, we'll talk a little bit towards the end, but it's a real popular design, and it's a good design for beginning astronomy. So before we talk about specs and stuff, one of the things we'll see a lot is we have the metric and empirical measures. They kind of go back and forth, but just kind of give it an easy reference here. We'll think of a quarter here. So 25 millimeters is roughly the size of a quarter, which is 1 inch. So if you have a 100 millimeter telescope, for example, then it's roughly about 4 inches. As the mirror gets up larger, that's the more quarters, so you can think the more quarters, the more pricey the telescope. Again, when we're thinking about the apochromatic, the apo being pricey, the coatings that are on the optics, you can think of price. So here's some important terms that we want to talk about when you get into choosing your telescope. A lot of amateurs will talk about aperture, and aperture is important, but I always like to talk about focal length. Focal length, we're going to find out tonight, it's what's going to help you determine, you know, a narrow or a wide field telescope. So depending on the object you want to look at, for example, the planets and the moon, you would want a telescope with a roughly long focal length to help see details, you know, in the planets. Also, like, you know, planetary nebulas and so forth. If you want like open star clusters, for example, like the Pleiades and so forth, you know, you want a telescope that presents a wide field. So we're going to talk with these in detail and kind of break it down. And again, we're going to use the refractor. It's one of the simplest in terms. And again, we have a lens out here, and the aperture is the size of the lens. The aperture in a reflecting telescope is actually the mirror. The focal length is from the aperture back to where the focal plane or the image is. That's the focal length of the telescope. The eyepiece actually takes that image and magnifies it and kind of looks at the image produced by the lens or the mirror. And then your eye is what takes that image and converts it to an image using one of the most powerful processors that we have on the planet is our brain. So the next slide, let's put a little bit more meat to this. I know that's a lot here. Again, let's take a look at it. So again, we have the focal length here. In this example, it could be a lens or a mirror. So we'll say we'll have an aperture of 102 millimeters. The eyepiece we're going to use is 25 millimeters. So the focal ratio is just the focal length of the telescope divided by the aperture of the telescope. And I'll talk a little bit more about that in a minute, what the focal ratio means. Also, the magnification is the focal length of the telescope divided by the focal length of your eyepiece. And we'll explain a little bit more here in a minute what magnification means. So when you want to choose your telescope, you want to think about focal length, aperture, and also your eyepiece. So let's talk about focal ratio. So we maybe be familiar with those two-sided flip mirrors that are in the bathroom, one with a flat surface and the other one that's curved, that you can kind of see a magnified view of your face. When optics, the lens or a mirror, it's actually have a curve to it, and depending on the curve, it actually gives you the focal length. Here we can see a real tight curve produces an f4, which is going to be a real wide field of view. Here it's a longer, the light path is longer, an f8, so it gives you a narrow field of view. So kind of putting in perspective here in size, if you're choosing a telescope with a wide field of view, you're going to see a wide area of the sky. A longer focal length, you'll get a narrow field of view, which is a narrow view of the sky. So let's look at this a little closer in detail. So through your eyepiece, here's an example. This is your window to the universe. In this example here, an f5 telescope, which is what I call a wide field of telescope. We'll look at the Pleiades star cluster here. So you can see all the stars within the Pleiades. And if we do magnify that, use a different eyepiece, we can still get a wide field of view here. If you have a longer focal length telescope, your field of view is narrow, so you don't really get to see all the Pleiades, you get to see part of the Pleiades. And again, if we use a different eyepiece and magnify, you see still a narrow field of view. So depending on the eyepiece, depending on the focal length, that's going to determine in your choice of what objects you want to see. For example, planets and the moon, you know, you may want a narrow field of view because you want to get into the details of the moon or planet. If you're into deep sky objects, then you want a wide field. Okay, so the focal ratio is the first thing that I like talking about for a beginner. The next is aperture. And aperture, as the size of the lens and mirror increases, it's going to determine, you know, how bright and how detailed an object is. And here's kind of an example with M13 through various telescopes. And you can see as you get in a bigger aperture, the image becomes brighter, and you can start to see the stars a lot clearer around the core of the open cluster. Over here, it looks a little fuzzy, but again, aperture, as it increases, you know, the better clarity. And again, remember, as aperture increases, the price increases as well. Here's a view of Mars through different telescopes. So again, for me, I think an 80 millimeter is a good starting size. If you go anything smaller, you're really just going to see an orange dot. I always recommend if you're going to go anything below an 80 millimeter scope, then you should look at buying a pair of binoculars. When we start getting up into a little bit of a larger aperture, you can start seeing like the disk of Mars, and as the telescope increases in aperture, you can start seeing the polar caps and some details on the surface. So now we talk about magnification, which is the eyepiece. And there's a relationship between the focal ratio and the aperture of the telescope that you use with the eyepiece to determine that image plane that you're going to see. Now the eyepiece has several features, and one we talked about earlier is you want it to be fully multi-coated. The numbers here on the eyepiece refer to the diameter of the opening of the ocular of the eyepiece. So again, a 40 millimeter here is 40 millimeters across here, and as the number gets smaller, the opening of the eyepiece gets smaller. And again, this is just an example of an eyepiece. Eyepieces, there's a lot of different varieties and stuff, and that's a conversation, you know, after the meeting if we want to get into. But this one here, Explorer Scientific, is a good quality and good for an amateur beginner's budget. Also here, if you notice, it'll say 68 degrees. We're going to talk about the apparent field of view of the eyepiece and what that means. What's nice about these eyepieces, they're parafocal. What parafocal means is when you focus the telescope, when you put it in the focuser, you don't have to move the rack and pinion as much as other eyepieces, so it gives it a nice touch. And also these have a long eye relief. If I remember, these are 18 millimeters, but for people that wear glasses, you want at least 16 millimeter or greater.
We have a 2-inch, 26 millimeter Explorer Scientific out of Kirby, and it's the most used lens we have.
Yeah.
I mean, I find myself going to it constantly.
Yeah.
It's just a good, got good eye relief, and it's got good curved view.
So again, there's a lot of different eyepiece manufacturers. So again, this is just an example. So let's look at these a little more detailed. So if I take an eyepiece, the apparent field of view, and I just hold that eyepiece up at arm's length and look through it, it's going to give me what I call like a window of the sky. Again, the sky is 180 degrees. If we look through at arm's length of, say, a 52 degree eyepiece, it's going to show us an apparent field of 52 degrees. Now when you when you use, looking through a telescope, again, this is our eyepiece view. A 52 degree will give you kind of a narrow field of view. So here we're looking at the Andromeda galaxy. So we can see another galaxy here, the core of the galaxy. There's a little star cluster in here off to the edge. So these 52 degrees give a narrow field of view. So you want to use those eyepieces primarily for lunar or planetary, or if you want to look at, say, planetary nebula, or really zooming in on, say, a globular cluster, looking at detail, you want a 52 degree apparent field of view of eyepiece. If you want to look at, say, galaxies, open star clusters, and so forth, when you get up to the 82 degrees, you can see that you have a much wider field view. Again, here you can see the core, but now you can see the little satellite galaxy here a lot easier. And then that star cluster within the galaxy, it's much easier viewed than in this eyepiece. And going back earlier into the refractor, I've kind of run the numbers here. If I have a 102 millimeter aperture, a focal length of 900, using that 25 millimeter eyepiece, it gives us a magnification of 36. So if I take the 52 or the 82 degree apparent field of view eyepiece and I divide it by the magnification, then I'm going to end up with, for a 52 degree, like a 1.4 degree true field of view through the eyepiece, or the 82 degree, I'll get a 2.2 degree field of view, true field of view of the eyepiece. And again, we can think back with the Big Dipper as far as size and angles, kind of gives you an idea of the view you would see here in the eyepiece. So there's more to the eyepiece that we want to talk about. One, we've discussed about the eye relief. It's the distance from the eyepiece to your eye. If they don't have a real long eye relief, then the top of your eyelid's going to be hitting the eyepiece. If you wear glasses and it's shorter, it will kind of interfere with your view. We're going to talk about the exit pupil. Our exit pupil, depending on age, will vary, but when your eyes dilate, you'll get roughly 7 to 8 millimeters. So the light that's coming through the telescope, the light path, you want it to reach the full capacity of the exit pupil. So how do we calculate that? We know the eyepiece focal length, and now we know the F ratio of the telescope. This is why I say the F ratio is important when determining the type of telescope you want. If we look in this example here, I just chose a real wide field telescope and a real narrow field telescope. So my choices eyepieces 40, 25, and 10. So using that, we see with the F8 40 millimeter eyepiece, it's going to give us an exit pupil of 5 millimeters. So that's well within the distance of our pupil of our eye. But if you notice that the F8 telescope, or I'm sorry, the F5 telescope, it gives you an 8 millimeter size light cone here, and that's greater than the 7 millimeters. So you have a little light loss as that light from your telescope and eyepiece combination. So you want to keep in mind when you're not only choosing your telescope but choosing your eyepieces to take into account of the exit pupil. And we can see here as the eyepiece, as we go from a large millimeter eyepiece down to a smaller one, the cone of light gets smaller. So in summary here, when you're looking for a telescope you want to choose, you want to ask yourself, do I want a wide or narrow field of view? Again, the optics, the lens, and the mirror is going to form an image, and that image is magnified. Again, think of that little mirror in the bathroom that when you look at, you see a magnified view of your face. But the important thing here is looking through a variety of telescopes, getting an idea, you know, if you want to go more into lunar or planetary, or if you want to go into more deep sky views. So again, the F ratio here, now that we can understand that an F4 is going to give you a wide field of view and an F10 is going to give you a narrow field of view. The aperture is going to, the larger the lens or mirror, is going to determine your brightness, increased detail. The eyepiece, it's going to give you the magnification of the image produced by the telescope itself, the image from the focal length, how well we'll be able to see detail and use different eyepieces to kind of zoom in to capture image. Again, we want to remember the fully multi-coated optics. We're going to look later at some choices of telescopes. Keep that in mind. If it doesn't say fully multi-coated, no. Coated, no. You may have fully coated. It has to say fully multi-coated. Again, we don't want any loss of light. And that equals the quality of your optics. Well, in choosing your telescope, we got to think about the mount. If you don't have a good mount, it's going to wobble. So let's look at the different types of mounts here. So we got the Alt-Az mount. We got two versions of those. One is the Dobsonian. One is this kind of saddle. These you want to kind of stay away from. It's going to cause the telescope to jitter and shake. The Dobsonian mounts, they're a lot heavier, so you're not going to get that wobble effect. Remember when I talked about the equatorial mounts, you want something real massive in here. You want something that's got weight to it. Here's an example here of this mount. You can see it's small. Depending on the size of the telescope, you're going to have that wobble factor. So you can have a nice quality telescope, but if your mount doesn't keep it from shaking, then you're not going to enjoy that nice image your telescope produced. So here's some examples that we talked about earlier. There's what we're looking for, the massive equatorial mount. Again, an arm here that's for the alt-azimuth that's got some mass. It's eliminates any of the vibration, and of course the Dobsonian. So here is an example of that telescope on the Alt-Az here. Again, we have some knobs here that we'll see in a moment that are slow motion control. It's a small refractor. This one over here is my first telescope that I ever built out of PVC pipe. Used a copier lens. It's been modified several times. I finally got it to where it has a 45-degree angle and a wide field eyepiece. The other thing is you don't have to buy a complete package for commercial optics, like say this one back here. You can get a large refractor, as one of our club members did, and you can build your own mount. Again, here we're using pipe and weight to help balance the scope. Made the tripod out of wood, so he has a real nice quality refractor, but he also made his mount. And I want to say astronomy is also about ATMs, amateur telescope makers. Think about that Dobsonian mount. You can take a refractor telescope and make a tabletop Dobsonian mount. So you can buy a real quality refractor make you a Dob base and you're set to go. And here's another example of the steel piping, the counterweight here. You've got a pad here to put your hand on to push or pull. Another lever here to move your telescope up and down. So John Dobson, he revolutionized astronomy. The Dobsonian mount, which we can see here, is what he came up with. In his days, he took ship windows and made telescopes out of those. So he introduced the large, what we call light buckets today, which you'll see here with the long tubes. But he's real famous for this mount, and they're very nice, easy to use. This telescope here is a 10-inch f4.5. It's one of my telescopes that I built. I didn't talk much about finder scopes. We'll get a little bit of that, but again, the finder scope, let's think of that as kind of like a binocular, but it's a monocular. So a good size starting finder scope is around an 8x50. Anything smaller than that, it's hard to see through. I'll put it in those terms. So let's look at some mounts. This is just an example of a beginner mount. Again, it's massive. It has the slow motion controls here for right ascension and declination. It has where you can sight Polaris for different latitudes depending on where you're at in the world. Here's that alt-azimuth mount I was talking about with the slow motion control knobs. You could put different telescopes on here. All the mounts will have a weight specification, so that way you don't put too heavy of a telescope on it for it to tip over. Notice the tripod legs here. You want at least about 2.5 inch aluminum or steel legs. Again, you want weight. You don't want anything to cause the telescope to vibrate or shake. So let's just look at some telescopes here. Again, there's many manufacturers: Celestron, Orion, Meade, Explorer Scientific.
Not anymore. Mead's gone.
Yeah, Meade's gone, Orion's gone, but you could still buy those scopes from someone who owns them or through aftermarket. But again, this is just an example. Again, this is 100 millimeter. We learned this is a catadioptic optic because it has a lens, it has a mirror in the back. It's on an equatorial mount. Again, we have an f14 here, that focal ratio, so we know this is a narrow field. It's for lunar or planetary. Again, we can see here the telescope aperture. There we have the millimeters, but they also give it in the size of inches. And again, we think of the 100 millimeters going back to our quarter, so you can see 4 quarters gives you 4 inches, so you can do that conversion real quickly. One thing I didn't talk about, the useful magnification. They do have that here. If you take the aperture of your lens or optic, if you multiply it by 2, for this here 100 millimeter, the useful magnification is 200 for this telescope. Again, that's a nice touch, because if you go to buy your first telescope and they're advertising a telescope that has 600 magnification, you don't want to purchase that scope, because again, it's not all about high magnification. The higher the magnification you get using an eyepiece, you're going to start losing the clarity of your object, and your object's going to look fuzzy. Again, here's a refractor, and again, if you're going to go below 80 millimeters refractor, then you may want to look at getting some binoculars. Here's the real beefy alt-azimuth mount. the red dot finder is a real nice touch. A lot of the smaller scopes will have a finder that's less than 8x50. Some of them come with a 5x24 finder. That 24 millimeter finder is very difficult to look through. So again, you would want a red dot finder. So think of X marks the spot, the red dot in the night sky marks the spot. Again, we know this is not a very narrow, it's an f8, so it's getting towards a wide field of view. There's the key right there, fully multi-coated. That means the optics, all the surfaces of the optics are fully multi-coated. So now let's talk about the Newtonian reflector. Again, it's not using a lens, it's using a piece of glass with a coating of aluminum for reflection. In small telescopes, you're going to find the plate glass or Pyrex are the most common. Pyrex has a better thermal expansion. The advantage, they can be ground more precisely than other types of substrates. 93 is a good reflectivity of a mirror. A lot of the choices are 91 and 96, but long as the main mirror and the secondary mirror are 93%, you're going to get nice views through your scope. And they use aluminum with a silicone dioxide to protect that aluminum surface. One thing I want to mention here, if you take your mirror out, if you ever clean it, please don't use Windex. You're going to lose the aluminum coating real quickly. So again, this is a mirror, but don't think of it as your mirror in your bathroom where you can clean it that way. So I talked about a telescope, gives you the best of both worlds. And again, we're going to look at aperture. That f6 is kind of in between the wide and narrow. So the focal length here is an f5.9. We have a large mirror, so we have 8 inches in diameter. Notice this telescope has a little fan on it for cooling. It's got a solid tube. A lot of your Dobsonian telescopes will come with a cardboard tube, which is nice, but over time that cardboard tube does break down. Has a very strong, and the mount, we'll see in the next slide, is not very heavy, but again, it's very sturdy. You won't have much of the shake. Overall, I highly recommend this. You're looking at a scope like this around $600. It varies depending on manufacturer. Let's look at those optical coatings. You can see in the description here, it has the aluminum, the silicone dioxide. The focuser here we'll look at, it's not your standard rack and pinion. It's a Crayford focuser. It has a dual speed on it. We'll see here in a moment. Eyepieces do come in a variety of sizes for amateur scopes, 2 inches, 1.25 inches. So this one will take a 2-inch telescope. Talk about the Dobsonian base. It's about 27 pounds, so it's not too heavy. The telescope assembly itself is 24 pounds. Total weight of 52 pounds. So again, if you're thinking of a telescope as far as moving it around, this is not going to break your back. Let's look at a little bit more of the features here. Again, we have a 8x50 finder, and what's really nice about this, it's a right angle correct image. That's going to help you with your star maps, so you don't have to think upside down, left or right. The 2-inch dual speed Crayford focuser. This little knob right here on the focuser, if it had one just like it on the other side, that's your standard focuser. But this one here has a smaller little knob to help you to make a micro adjustment to help you, the image produced by a telescope, to get it in focus with your eyepiece to get it more precise. Now we talked about different eyepieces, the narrow field and the wide field. In this scope, we get a 9mm with a 52 degrees, so we know we're going to get some magnification for the planets and the moon. It also provides a 68, a real wide field, 30mm. This tube extension here, it goes between the focuser and the eyepiece. Again, we talk about the parafocal eyepieces. Some eyepieces that are not parafocal may need a little more distance of travel, so they give an extension tube in there. It's a real nice touch for different eyepieces. I didn't mention about filters. There's a variety of filters, but it's a nice touch to have a moon filter because the moon does get very bright. Again, filters can use for certain planets and stuff to bring out details, or there's filters to look at certain planetary nebula to help certain wavelengths in. But again, for a beginner, that's a topic for after, depending on what you're interested in looking at. The other things, 4-slot eyepiece tray, that doesn't really make or break the scope, but it's real nice. They give a laser culminator, and again, that's another conversation later that we can discuss of what that means. But they give you a lot here for the price, and if you really got a budget of around $600, I highly recommend this type of telescope. But it's not the type or size or quality of the telescope. It's the person that's behind the eyepiece that's most important. We go to star parties and see these big light buckets and stuff, but you can get a lot out of a small refractor telescope, even at a dark site. So again, it's not what type of telescope you have, it's the person behind the eyepiece. So using your telescope, we got a lot of different things that once you have your fully multi-coated optics, your eyepieces, 2 of our nemesis out there is clouds, which are out tonight. Also the one that's very bad is light pollution. As you can see here, you can't see any of the sky, but over here, if you have a full cutoff, you can see the night sky. So again, depending on your location, is how well you're going to be able to see the night sky. Here's the aperture telescope. You can see it fits in kind of a small 4-door car. Again, a lot of people beginning astronomy, a lot of people say, oh, get the big aperture scope, and then you get it home and you can get it back and forth in and out of your house, but now you want to go to a dark site, but now it won't fit in your car, so now you're kind of like stuck with a large scope and can't take advantage of the dark skies. Other thing, you want to have good rest. You don't want to be tired because again, it's going to affect your views of the night sky. And with the Newtonian type telescopes, it is a learning curve, but you do have to culminate, line the mirrors up. The real nice thing about the aperture telescope, a lot of the reviews and people I talked about, once you get it out of the box, it's already almost perfectly aligned, so you can take it out and view with it with no issues. So we talked about telescopes and optics, so let's talk about one of the most important instruments is our eye. During the day, our pupil is very small. At night, the pupil grows in size. So again, with our age,
I'm at 2 now.
yeah, we just, as we age, and again, it depends on the health of the individual, it depends on the individual, but after 30, it said about every 20 years, you lose about 1 millimeter of your your pupil diameter, but it varies. So dark adaptation. This graph here shows this long curve here. It takes almost 30 minutes for your eye to adapt. There's a protein in your eye called rhodopsin. It's in your retina, and what helps us see in the dark. A lot of people call it purple vision because in the wavelength of light, it's within the blue-purple part of the spectrum. So again, when you go to a dark site, you want to allow your eyes for at least 30 minutes to get dark adapted. So that means you want to use a red flashlight, no white flashlight. You want to make your cell phone have a red light on it, because again, any source of white light will affect your pupil size. Clouds are a factor. Also, the heat sources from homes and stuff also play a factor. So it doesn't matter what type, a telescope, quality optics, so forth. If you have a heat source in there or the sky, there's two terms we talk about: transparency, how clear or clean the sky is, and also seeing. Seeing is how much water vapor is in the sky. So if you have a lot of humidity and stuff, you're going to get the atmosphere that's really bouncing around. And that, with a telescope, with it being magnified, you're just going to magnify that waviness. Again, the jet stream, if it's overhead, it's going to be windy and stuff. If you have a mount, you're going to get the wobble in it. Also, the jet stream is in correlation, with the transparency and seeing, as you'll learn as you get more into studying astronomy. So a hefty mount will kind of minimize that if you have winds that are 8 miles per hour or lower. Now that heat wave I talked about, there's a scale to kind of rate the night sky. If you're looking at a star and it's real, the heat is around, you're going to get this blob, blurry image. This is just like this pointer here. It's dancing around. But as you get away from the heat sources, as the night temperature and the atmosphere starts to cool down, that waviness is getting lower. And again, it affects your image. We can look at Saturn here. When you have a lot of heat source or turbulence in the atmosphere, you're not going to get a very clear image. As everything improves, you can see that you start to see a lot more detail in your object. So here's a picture of the moon taken with my 90 millimeter telescope. The atmosphere changes overnight, but as you can see here, this crater, it's got real soft detail, but if we look over here, you can kind of see a little crater that pops into view that you don't see here. Looking at these craters here, over here, you can see the little hills and domes in this crater that's absent in the other. So just because the night may have a little bit of atmospheric turbulence, there are times when you do get real crisp views. And over time, your visual acuity will get better to look for those details. To kind of help with all that, Astropheric is a nice program that talks about cloud cover, transparency, seeing, wind speed, temperature, and dew point. Here we can see the clouds. It's clear over Louisville. This was taken a couple nights ago. But the dark blue here represents clear skies. The white represents the clouds. Good transparency is going to be the blue. Good seeing is going to be a blue. When it gets down to the white or light blues, that means that seeing and transparency is not in our favor. We also have the Bortle scale in beginning astronomy. And what that is from the city, you're going to have a real bright light that pretty much blocks out the brightness of the stars. But as you get further out into a location that's dark, the location gets better. So location is key when using your telescope. I hope you can see in this image, this is a camera view and this is the eye. Depending on where you're sitting sideways here, I can really see the Milky Way. If you're straight on, you may not see it. But again, visual astronomy, it's almost kind of a black and white, but when you get out, if you can see the Milky Way and see the stars, you're going to be in for, with your telescope, a real treat in looking at deep sky objects. So we're coming to a close here. Setting up and tearing down your telescope, you want to practice during the day. You don't want to be doing that out at night, trying to learn your telescope. So you want to do that as you get a new telescope. You want to plan ahead. You want to check the weather conditions, make a list of objects. You want to make a light shield if observing from your backyard to block some of those lights from the neighbors. If you're observing from an urban area, usually after 12 p.m., the night sky seems to settle down and the night temperature acclimates, so it's the best time to view. As the sun is setting, you want to align your telescope with the finder, so that way you can star hop and point your scope to find objects. And storage and portability is the key to using your telescope. If you're not able to store, or you have a challenge of getting your scope in and out of the house or in a car, then you won't be using it very much. So here's some examples. Again, here is setting up. You want to set up, during as the sun's setting, all the little weights and mounts and so forth. You want to get those aligned and balanced with your scope. You have your star maps. Here I have tabs prepared, my star map out. So I have the tabs represent my list for the nighttime objects I want to observe. Here's an example from my backyard. You can use a tarp, some shepherd hooks to make a light shield. Use a half dome tent to kind of block some of the lights coming from the neighbor. Over here, you can see I have, the tarp, some of the lights here that come on.
If you could go back to the previous slide.
Yes.
This is something I wanted for those who don't know. He's got that tarp on the ground for a very good reason. When you're out in the dark and you're looking through your telescope and stuff, and you drop stuff on the ground, it's a lot easier to find it when it's dropped on a tarp than when it's dropped in the grass. Because a lot of times at night, you drop in the grass and it just disappears.
Yeah, that's a really good point. Having a tarp there, if a little screw or something does fall, it's a lot easier to find it on the tarp. If it falls in the grass, it can be lost forever. So here, as the sun's setting, I'll use the poles, the phone tires in the back to align my finder up here with my main scope. And once that's all set and stars start to come out, I'm all ready for viewing. So that concludes the program for tonight. Wish everyone clear skies. Again, purchasing your first telescope, please come join the LAS. Come to a star party, look through a variety of scopes to help you choose which type of scope you would like to purchase to begin your journey into astronomy. So we'll open up for questions?
He had an emergency at home. He's,
So whose scope is in that?
that's Pat's.
Pat's scope?
That's Pat's scope. That's what he dragged me out there and said, hey, set this up.
So who's gonna deal with it?
I'll, he said, bring it to UAC.
So, budget's a concern, obviously.
Yes.
We got these two guys, they're hard on stuff.
Can we show them?
Maybe sub 500?
Oh, I can, can I say something about that?
Yeah,
We have scopes at the library, at several of the library branches, and you can actually go and check them out. And so I would recommend you do that, just because it's a kind of a tabletop. It's not like that, it's more like those Dobsonians you were seeing, except it's small. And so they're really sturdy, and they give great views, and they're easy to use, very easy to use. Anybody can learn how to use them. But you can just check them out at the library.
yeah. That's an excellent,
That's a good place to start.
that's an excellent question. Let me show you here. This is a company, B&H. Let's go to optics here. Go to telescopes. Yes, that's. So again, see if I can scroll through his screen here with. So again, some of the things that we learned here. Okay. So again, we have a Celestron travel scope here. Well, let me get the. There's fully coated optics. Again, that's not fully multi-coated optics, but if you wanted something just for a beginner at a price, this is a good like starter scope. The tripod, you'll have a little bit of the wobble factor, but you know, let's scroll down to, let's look at these here. Here's your Explorer Scientific, 80 millimeters, around 200 bucks. Fully multi-coated optics. Again, this would be good for, say, your family or whatever. You can have the tripod really low. It's durable. The tripod is made out of an aluminum. So again, 80 millimeter would be good for a starting scope, you know, with your family and so forth. Would be a recommendation. Again, you're getting the optics is what's going to give you the best views. If we go here to this Carson scope, even if we went to all the details at 200, you don't see anything in there that talks about any of the coatings on the optics. And this would be a scope that would give you that chromatic aberration. We go down even further. Let's see. Here we have another Explorer Scientific, but they got anti-reflection multi-coated. So you can see here it's not the fully multi-coated, but then it's got a little bit higher price, but it's got a different type mount. That's what's driving that. But for 200 bucks for a small refractor that's fully multi-coated, comes with a, I forget what eyepiece that came with. Where's that on it? Yeah, 25 millimeter eyepiece. So again, if you run the numbers on that, you're going to get a full capture of the moon there, about a half a degree.
Hey, Carl?
Yes. Do we have a question?
No, I have a comment.
Okay.
There's hordes of people outside wanting to go to the telescope.
Okay,
And Pat only has his one. Is that one usable?
that one is usable.
Can we haul that outside too and show them?
I can haul it out, but I'd rather be behind it because the tripod's a little wobbly.
Oh, sure.
Yeah.
You can do the demo, too.
Yeah,
It's totally cloudy out.
I know.
Yeah.
I'm surprised that anybody
So,
shows
yeah.
up in the dark.
Yeah, I don't think
So again, does that help answer your question?
Yeah.
There's also a heritage refractor. It's a tabletop. It's a small Dobsonian. Those are really good as well for, you know, small children or family getting into astronomy.
Okay. Do you do much photography through those? Like I've read about, you know, the aviation grade night vision, right, and the adapters. Does anybody have experience with that?
I'm not I don't have experience with that myself. All these telescopes I talked about tonight are visual. It's a whole nother ballgame when you start talking about, you know, attaching, you know, a camera behind it. A lot of the concepts are still the same as far as a wide field or narrow field of view. But again, that's a different conversation when we get in. It's also really important with a mount. I mean, if you're going to take pictures of the moon, you don't need a hefty tracking mount, but when you get into the really deep sky, the mount is what's really critical.